not start with a clean slate like I've always, like in the past, in the code here, I started with a clean slate of the py file, which was blank, and then you modified that. It's always easier to start with something which is populated. So I took the hello.xml example. That's the only thing we'll be using, and we'll just modify it. As we modify it, we're going to look how it looks on the viewer. So you can open the viewer by just typing in here Python -m MuJoCo.viewer. And then if you have on my Mac, actually, I need to write Python 3, just so you need to be mindful of that. Okay, so here's the viewer. We can drop the hello.xml. But let's just rename it. I'm just make a copy. I'll call that. We call that something else. Let's call that Planar 3R. Okay, so planar manipulator with 3 revolute joints, drag drop, and then you can reload it multiple times and it just falls. Okay, now here's the thing you can do. You use this in this mode. This part is not very useful, I think, at least for now. So you can actually get rid of it. I think if you press Shift Tab, it goes away. If you want to get the left side, drop the left side, the UI on the left side, you just go Tab, drops away. You can get back Tab. So Tab gets it back and forth, and then Shift Tab will get the right side. Okay, so we don't need the right side. We might need the left side, so I'll keep it. Okay, now if you've seen my video, you can actually modify the XML file and then just go reload. Okay, so you can reload it in any number of times. If you wanted to wonder how you can do a shortcut to this, I think if you press, anyway, it's usually if you do right click, you should see the shortcuts here. I think usually when you hold it, it comes, but it's not showing. But if you right click, it shows the shortcuts. The shortcut for reloading is Control L. So it keeps loading if you use Control L. And then sometimes it's good to use shortcuts. Sometimes just use this keys. Okay, so we're going to modify the planar file, the one I just called planar XML. So let's just open it here, and then it has exactly what it's supposed to have. Just the block being dropped. First thing I'll do is change this plane. Let me just put a darker shade here, 0.9, and then also remember that our size was about 2.5 is what we used to make it big enough. So I'm going to make this 2.5, and then always good idea to check. So Control L will do it. Okay, and then you can change the view, keep it like this. Okay, now I'm going to change, start by eliminating the joint. We don't need a free joint. In this case, we don't want anything to be dropped. We just divide a geometry. I'm going to create this box, use a box, but it's going to be basically a box on the horizontal direction, because if you see this figure, I'm going to define a red box along the x-axis, and we know the length of that box should be, well, it should be 1 meter or 1 unit's length. By the way, MuJoCo doesn't have any units. Whatever units you use is what you think units are. You could use centimeters, meters. It will have the same dimensions, and your interpretation as to what you're going to use. You have to scale everything based on that. So we're going to put a 1 meter long box. Let's go here. So box along the x-axis should be 1 meter. And then what MuJoCo likes is to put it half of that length. So when you say 0.5, you're really defining half of the length you want. And then you want it to be a red box. So just go and reload. So Control L will do it. So now you see that box, and it doesn't fall. And it doesn't fall because there's no joint. right? That's one reason why it doesn't fall. The other reason why it doesn't fall is because this is actually the XY plane. So you will not even see it if it falls because it's going to fall down. We can actually move it right down. Let's move it to 0, 0, 0. Okay, that won't change much. Okay, we've defined that. Now, the starting point of any of your XML creation is to figure out where the axes are. Okay, the axis defines the origin of the frame. You always want to put the origin of the frame because once you define the origin of the frame, the axis, you can use that to then set the pin joint and so on. So to see the axis, there's an option here in rendering. Go to rendering and then choose a couple of frames. The world frame is the single frame. It's right there. If you want to see geometric frame, so each body, all the bodies which are by default available are regular geometries, like a sphere, a capsule, cylinder. They always have the axis at the middle of the geometry, like this one. There's another axis called the body frame axis. Okay, this one is sitting right at the geometry axis. That's where that's the one which we're interested in. We want to move that axis right at the tip over here. So that way we can use that to define the pin joint. So that's the first step. The way you move the axis from here to there is by defining the position label here. So if you define position, I'm just going to define 0, 0.5, 0, 0, and see what happens. Okay, reload. So Control L. So it moved to the left. Now, the way this works is the geometric axis never moves. It's always the same. But the body axis can be moved. And by specifying a 0.5, what you're essentially doing here is you're moving it relative to the geometric axis. So when you move it 0.5, like I've specified here, the geometric axis actually moved 0.5 with respect to the geometric axis did not move, but the body frame axis moved in such a way that the geometric axis is now at a distance of 0.5. It seems a bit confusing. So body frame was here, same as the geometric frame. By specifying a 0.5 over here in this tag, what happened was the geometric frame remained as it is, but the body frame moved such that the geometric frame is 0.5 meters from the body frame axis. So always remember that if you want it to move to the left, in this case, negative 0.5, you just specify the negative or whatever you want, and you'll get the desired effects. That's the piece which is, I think, a bit confusing, but with this visualization, you can actually take care of it. So once we define that, I'll only stick with the, so once you define that, you really don't need the geometry axis. You can live with the body axis. So now we can define everything with respect to the body frame axis. So we'll define a pin joint. So for that, the tag is joint. The type is, they call it the hinge joint, which is a pin joint. We want the axis to be sticking out in the Z plane. So axis equals 0, 0, 1. So that's sticking out in the Z axis. And then if you want, you can put the position, or you can ignore the position. But by specifying nothing, it'll actually put the pin joint exactly at the body frame. So if you save this and you reload this, so Control L, you don't really see the joint, but you can click on this. And you can see it over here. The best way to see it is probably to turn this around here. Oh, I need to get rid of the, let's put none. So now there are no axes. Okay, so now you can see that this thing is sticking out. That's basically the joint. Now we'll do a few more things. I've not put this on paper, but I also would like to define the mass of the body, and then I want to define the location of the mass and the inertia. So for that, you'll use a tag called inertial. For the inertial, we have these parameters: mass of 1, That's what I decided. We want to define the position of the mass, where we want the mass to be located. So now we want to locate this mass maybe in the middle, right? Right over here in the middle. Again, everything is with respect to the body frame. The body frame is here. So this location, the middle of the box, is going to be at a distance of 0.5 along the x-axis of the body frame. The body frame is here. So along the x-axis. So this would be, position would be 0.500. And then it will not let me run the simulation unless I define inertia. So I'm going to define some inertia. It's not very important here. 1.1000. And we'll talk about inertias a bit later. What does this inertia mean? Okay, so with that, let's do Control L. And then the question is, where is exactly the axis? So you can actually go here and click on center of mass. You can see it's right there. Again, you can, of course, play with this parameters to see where it goes. For example, if you put 0, you'll see that it actually gets placed on the body frame. So we can do Control L, and then it goes right there. We don't want that. Okay. Always good idea to name the bodies. So we'll call that name equals body1. Always good idea to name the joint. We need this sometimes because we want to specify maybe an actuator, which will come later. So we'll call that name equals joint1. I think you can fix this sort of light if you go to the XML. It's probably the light which is causing this. So if you move it further away, let's say X, Y, Z, so you move the light up to 100 whatever units, I think that'll go away. Let's see if that works. So if you want to reload the scene, which you have to obviously do once you make changes, one option is to press reload, which is here, or you could just do Control L. And so it's maybe a little better. So I removed the light. Okay, yeah. So we have this now. Let's move on. What we need to do here is, based on this, we need to put another link, and it's essentially going to be very similar to this one. So just makes more sense to copy paste. So let's go here and copy paste. Now there is one thing here. Once you copy paste, that one way to copy paste is this way. So here you can see what I did as the body tag started, ended here, and then I copy pasted it here. What this does is actually it creates another body which is separate from the previous body because it's not nested inside. So if you run this in here and you say reload, the name is repeated. So let's change the name to body2. This will also complain, so join2. And then if you do that, I think it will just, it's a mess because it's on top and then it's a collision, so it just moves. So avoid this. Also change the color because that's not what we want. We want, I think, a blue color. So I'll just keep it consistent with my figure. So 0.9, that's for blue, RGB. And if you want, you can move it further along. Let's move it to not the X, not the Z, but the X. And then if you run this, reload, you can see the joint. Go to rendering, and then you can see the joint here. And how do I convince you it's a separate joints? Well, the easiest way to do that is to turn gravity on. Let's go here, turn in setup option, gravity equals. So remember that this is the XY plane. So I want to set the gravity along the negative y direction. So 0, minus 9.81, 0. Okay, and go here. And then now reload. So Control L. hey, it's not running. What's the problem? Well, if you see this, it's actually stuck against the ground. So it's colliding with the ground. It's not moving. So I need to move it slightly up. So what I'll do is I'll go here and then I'll change this position. So it's 0, 0, 0. So that 0 is stuck to the ground. Let's move it slightly up, 0.1, 0.1. And then it should probably work now. Not yet. Okay. Maybe move it slightly away, see if that works. Yeah, okay, so it was just colliding with the other one. But yeah, that's a pendulum, that's what you expect. So you can see that two separate bodies. We're not really able to connect. This is what you did for your homework. Let's connect them. So the way to connect, let's pause this. The way to connect the bodies is to go back to the XML and actually nest this inside the first one. So go here and nest it inside. So you can see that this body tag is open, and then this body tag appears, but it's not closed. And then I close this one, it is closing body 2 tag, and this is closing body 1 tag. So remember to nest it if you want it to work. Now, if you, let's go back and change this to 1.0. And then I don't need to move it 0.1 because this is the local frame, right? It's how it's attached to the previous frame. So I don't really need to 0.1, otherwise it'll actually go 0.1 above from the previous frame. So let's go there, just do a reload. Now they're attached, run, it's a double pendulum. Okay, pause. Okay, so we got, let's pause it, reload. We got it there. Now let's just turn gravity off. I'm interested in gravity. Okay. So let's see if we got this right. So we have mass, hinge joint. We might want to check the location of the center of mass. In this case, there's a mass of 1 at 0.5, and then there's for joint 1 or body 1, it's also the same one. If you go here, and then if you want to check that as the only thing we've not checked, and then we can move to the next link. But if you go here and then click on center of mass, you see, it's okay. Here's the thing. It's going to tell you the center of mass of the combined system, right? So there's a mass 0.1 kg right here, 1 kg there, and the center of mass of that will be right there. If you really want to visualize center of mass second one, what you can do is you can make the mass of the first one 0, which means that effectively the center of mass will move to wherever the center of mass second link is, but it won't allow you to put a 0 mass. So what we'll do is, if you go here and then change this to a very small value, 0, 1, it's a very small value. So effectively, almost all the masses to body 2. And now if you go here and then if you do reload, so Control L, it's paused. So let's go run. Maybe I did not save it. Let's see. I did not save it, I think. Control S. Okay, there it is. So its mass is right there. That's just a way to check. Okay, we got that. Let's move back to the last link, and then we should be done. So, okay, the last link, we can just copy paste this. So it's going to be nested, and then it really, like, unlike Python, it really doesn't care how you put this. I'm just going to put the tab spaces here just to make it easier to read. Let's call this body 3, joint 3. And remember that this one is going to be of, I think we decided this is going to be of length, L3 would be 0.25. So when we give this, we need to give half the box length. So if we go there, we specify this will be half of 0.25, so 0.125. The hinge is the same. always you should have the joint at 0, 0, 0 because the body frame is on the pin joint. And then this length position should be 1 to 5. And then I'm going to change this to 0.2, 0.2, 0.1, 0.1, 0.02. Let me just consistent with my notes. Yeah, let's just do that. It's a smaller mass, and this is just random values. And then change this mass to just add it 0.2. Okay, so this is going to be a problem. We can see what happens. Let's go here. It's not been set. Reload. Let's remove the center of. Let's just. Okay, it's red link, and you can barely see it. Let's just change the color. Just go and let's just make it green. So RGB, the second value is green. Okay, so what has happened is, it's first of all, it doesn't look like it is 0.125. It looks longer. Let's see what error did I do. Yeah, here's the problem. I chose it to be 1 meter long. This should be 0.125. And then this is still not correct because the position is not right. Okay. Oh, yeah, it is actually right. So the body frame is the look. So we need to specify where this body frame. Let me just turn that on. So we need to specify where this body frame is relative to this body frame, and that's precisely the distance here. So this body frame 1.0 means that body frame for body 3 is at a distance of 1 meter from body frame for the previous one. And so that's right. So it all worked out. So this is our manipulator. You can reload. Nothing is going to happen because it's all, there's no gravity. We can actually set the initial position by using keyframe. But before that, let's just set the tip. We need the end effector position, like this point, right? And actually MuJoCo has a way you can get the tip position. So let's just put they call it a site to specify the tip. And remember, the tip is on body 3. It will move with the body 3. So let's create a tag called site. We give it a name. You can call it end effector. I just decided to call it tip. It will have you have to give the position of the tip. So where is it with respect to everything with respect to the body frame? So the body frame is attached to the pin joint of the third body, right? So this figure, this is the body frame for this. So we need to attach the tip at L3. L3 is 0.25. So go here, and then position is along the x-axis 0.2500. We need to specify, if you want to see it, we need to specify a size. So it'll show like a sphere. Let's choose a size of 0.05. And then we want it to be a distinct color. So we can specify RGBA. I decided just to go with red. So 100. And then opacity is the last tag, which is 1. So if you go now and then reload, Control L, you can just barely see it's over here, red. Okay. Now, sometimes you might want to load it with a different position. There is something called keyframe, which helps you do that. So what we'll do is outside the body tag, but world body, we can define what is known as a keyframe. So this one is defined slightly differently, keyframe, and then you need to have the end tag, just like this MuJoCo and world body. And then within this, we'll just specify the keyframe. So the key is a name, just some home position. Q pose, I'll get to what Q pose is in just a bit. And then actually, all these commands which I'm saying are just not falling from my memory, but it's just that I've used this with the documentation. I'll show you the document in just a bit. So we can specify the start position of the joint angles. So by default, the angles are 0, 0, 0, right? But let's say that we want to change the first link to be at 90 degrees. So 90 degrees is 1.5707. So pi divided by 2. So now if you go here, and then if you do reload, nothing happens. But if you do load key, it just goes to that. It uses that key to load. You could change some other angles if you want. So for example, if you want to change, I think we decided that we want to go, the blue link should be horizontal. So that would be negative 1.5707. And then if you want the final link to be up, the green one, you go 1.5707. Just go here and then say reload. Bad formatting. Go back and then so reload. Nothing will happen, but you need to load key. And then this is what I think we did the same thing in our earlier simulations without MuJoCo. Okay, so this is the position just from the key pose. So we got this. If you want to turn gravity on and see this, actually it looks pretty, the animation, if you turn gravity on and then if you run this, it'll fall and then shows this very interesting way, and we'll talk about this in just a bit. So you could pause if you want to use the key, and then you could run. So what happens here is there's a collision, and the collision basically leads to this. But if it was free, there was no collision, then it actually shows some very interesting way we'll talk about in just a bit. I'll just pause this. We don't want gravity on. Okay, so where did I get all these XML commands? Well, if you go to MuJoCo.org and then go right to documentation, you need to go to the XML reference. Everything I talked about and did this class or for the homeworks came from here. So example is, let's say that we want to figure out one of the more common attribute is body. So if you want to figure out how all these appeared, you have to go to the documentation and see what is defined against body. So if you see body, that's what we want. So body has MuJoCo. Body is nested in MuJoCo. That's what it's saying. Body would have position, quaternion. Actually, I used position and I used name. So if you go here, I had tags, name and position. There are other tags which you can see over here. They've given you other tags. Sometimes you need to turn the axis, and we'll talk about this in just a bit when we do the UR5, but you could use quaternion if the axes are not along the axis shown. Then there's inertial, which I also used. So inertial, it's mass, position, full inertia. So if you go to the documentation, it shows position, mass. There's diagonal inertia, which will be used very often, but then there's full inertia, and just keeps going. If you want to see the keyframe, yeah, so MuJoCo keyframe, and that's precisely what I used here. Keyframe, and then within keyframe, I had a name. I had a Q pose. Q pose is basically joint angles. We'll come to them just a bit. And then you could specify a velocity. You can also control. These are three things we'll be using. You could also actually specify time. I didn't know that. Okay. So that's the first step. We've got the MuJoCo viewer to give us the XML. So this shows you how to take what we learned in the class with homogeneous transformation or the depiction of the body axis and transfer it to MuJoCo. Let's sort of close the loop. Now, if you have this XML file, can we now show that this XML file will produce the same results as our forward kinematics file, which we created earlier. So the forward kinematics file